Now we'll discuss about some of the physical properties of the geometrical isomers. By studying these physical properties, we may able to distinguish between the cis and trans form, and we'll check how it is possible. So the first one is dipole moment. Remember, what is dipole moment? Dipole moment is due to the difference in electronegativity. And remember, dipole moment is a vector quantity. It is represented as a vector term. So whenever you are taken this molecule cis butadiene, this group CH3 group is this group, and you have this CH3 group also, and this carbon is actually sp2 hybridized carbon. Remember, it is sp2 hybridized carbon. This also is sp2, and this is sp3. This also is sp3. Remember, sp2 hybridized carbon is more electronegative than sp3. sp2 is more electronegative than sp3. So what happened? So the head of the vector is always projected towards more electronegative atom. So this carbon is sp2, which is more electronegative than this carbon. So here the head is projected towards this direction, and here also the head of the vector, dipole moment is a vector, its head is projected towards more electronegative atom. So what happened in this case? Both the dipoles are oriented in the same direction. And you know, dipole moment is a vector quantity which is a summative property. Vector is a summative property. So whenever these two are on the same direction, then the net dipole moment will be in this direction, and which is mentioned here as mu 0.33 dipole or dB, not dipole. D stands for dB. It's one of the unit by which dipole moment is represented. Look onto this molecule, what happened? Here again, the dipole vector is projected or oriented, or head is projected towards this direction, and here it is in the opposite direction. So the vector are on the opposite direction. So what happened? Net dipole moment is cancelled and it is 0. So what you can conclude is, this is the conclusion, the cis isomer will have certain dipole moment, while the trans isomer, the dipole moment will be almost nil we can say. So the cis isomer is a polar molecule, while the trans is non-polar. That's the difference. So this is nothing other than, since both the dipoles are oriented in the same direction, while trans dipole are oriented in the opposite direction, and hence net dipole is 0. Now we'll discuss about what is called we'll discuss first boiling point. Boiling point. See, whenever we're discussing about the boiling point, remember it is related with the intermolecular force. Whenever the intermolecular force increases, definitely the boiling point also increases. As the dipole moment increases, the polarity increases, and intermolecular forces also increases. See, polarity is the key in determining lighting boiling point, as it causes increase in intermolecular forces, thereby rising the boiling point. So we know the cis isomer is more polar than the trans isomer. So what happened? Since the cis isomer is more polar, it will have more intermolecular forces, and thereby the boiling point of the cis isomer is greater than that of the trans isomer. Boiling point will be higher for the cis isomer. We will discuss about the melting point. See, remember, melting point is for solids. We usually speak melting point as for solids. So for whenever the packing is more efficient, as the packing becomes more efficient, what happens? The molecules are tightly packed, and thereby the melting point will be increased. So whenever the molecules in a solid are more symmetric, then the packing will be more efficient. And if the packing is more efficient, as I told you, the melting point will increase. So this is a key point. Symmetry is key in determining lighting melting point, as it allows for better packing in the solid state, even if it does not alter the polarity of the molecule. Look onto the cis and trans. Definitely the trans is more symmetric. You can see across a double bond, and the trans is more symmetric. If trans is more symmetric, definitely it will have high melting point. So you can say the melting point of trans, since it is more symmetric, it will be higher than that of the cis one. Now this is the conclusion. Thus in trans alkene, which are less polar and more symmetric, have lower boiling point and higher melting point than cis alkenes, which are generally more polar and less symmetric. Anyhow, two molecules which and there are physical properties are compared. So you have cis butyrene and trans butyrene. We're going to these two molecules. So what is the melting point in degrees Celsius? It is minus 139 for cis and minus 106 for trans. Minus 106 is higher. Minus 106 is higher. So trans have a higher melting point. And look onto the boiling point in degrees Celsius. Cis 4 degrees Celsius while trans 1 degree Celsius. So this is having higher boiling point. So that's all about the physical property and also about the geometrical isomerism. And we'll discuss about the stereoisomers, optical isomers, not stereoisomers, optical isomers in the next class.